Yeah, Mr. Sanjay, he has joined.
Okay,
Akshay.
so we can start the session, sir. Yes, sir. Ma'am, start the session, ma'am.
Good evening to one and all present here. We have amidst us new resource person, and we are on the day 4 of the 5 days online FDP program on AI tools for effective teaching, learning, and assessment. We have amidst us Mr. Akshay Rupan, AI engineer, J Impact Coimbatore, for the topic AI application and audit. So introduction will be given by Mr. Arun sir. Please, I'll hand over the session to you, sir. Thank you.
Absolutely. Thank you so much, ma'am. So, again, good evening, one and all. So, as we're taking different approaches in the with the teaching fraternity on using the AI tools, right? So today, our friend Mr. Akshay, who has demonstrated so many AI-based projects during his tenure, working for as a freelancer as well as now having joined the company, he will demonstrate you some of the use cases on not just audit, but more like a student mark analysis, right? So especially we all have come through the world of artificial intelligence, which effectively the previous era was more focused on the machine learning, deep learning, correct, and then further evolution resulted in generative AI, and then from generative AI we also saw in the day two how we can build agents and so on, right? So, and then comes the MCPs, and it goes on multimodal and so on, right? So today we're going to just piggyback on that whole ML approaches, which most of you I assume would already be familiar with some of the things, but we just want to show you how the components of the generative AI can be linked with using some of the ML approaches, right? So Mr. Akshay would actually walk you through on what are the simple frameworks that we can adopt, it especially when it comes to the student and marks, which we all deal a lot with, right? How do we analyze the set of marks, or how can we generate some of the standard inputs just by writing the codes, right? A simple set of codes. So over to you, Akshay, if you want to just get going. Thank you.
Good evening, guys. Can you hear me?
Yep.
Okay, cool. Hold on. Yep. Good evening, guys. So today I've been said this is a session for helping people know about AI. And before we step to the world of AI, which looks very fascinating and interesting, we have certain building blocks, things which actually make AI, right? A lot of people don't know what that is, and they're like, "Oh my God, this is some magic! A machine that just predicts and is able to do a bunch of stuff." But it is not so, right? In reality, the background is very simple. Okay, it's just a bunch of math, basic math, advanced math, and really good complex math, right? A piggyback on the works of hundreds of years of, research papers. There's a bunch of things going on. So today, yeah, today we're gonna get into the world of AI and just go through the very, very basics, right? The extreme basics. This is like the building block. So if I show you all these things, you will understand how things come to be and how a machine can be taught and learned. So I hope at the end of the session, you guys are gonna think, okay, this isn't big deal. I'm a machine learning engineer too, probably. So, but this is a step in the right direction, and thank you everyone for joining. Yes, regarding this session, I would be explaining some stuff, and I would give you a simple code which can run, and hopefully you can take inspiration from it and do something. Okay. So my session is pretty straightforward and easy. If anyone has any doubt, you can stop me right then and there and ask me, what is this or what is that? Okay. Cool. I hope everyone is ready. We'll present some stuff. Hold on. I hope you guys can see my screen. Is it visible? Yes?
Yes, yes.
Okay, cool. Okay, we'll go on presentation mode right now. It's not that difficult. Okay, so regarding today, we're gonna see something about what regression and what correlation and everything is. Okay, these terms might be familiar, but we'll just go through the basics and we'll see how you can run this in Python. And before that, you need a bunch of prerequisites for that. Okay, so we'll start with understanding. I think we can go with correlation. Okay, so what correlation actually is? It's nothing too hard. Okay, hold on a minute. Yeah. So correlation is nothing but the relationship between one item or and another item. Okay. Yeah. Right side. Yeah. Correlation is simply, a mathematical way of saying, hey, this item is related to this item, and it's related because of these factors. Some basic things that you would need to know about correlation is the fact that correlation is a number. It's a integer, and anything that's minus one means it's inversely proportional, meaning that the thing that's happening is exact opposite to what it's supposed to produce, and vice versa. To put an example, let's say, okay, so the more sunny it is, right? For example, let's assume the temperature is like 100 or 110 Fahrenheit. Okay, we don't want that, but let's just assume. Let's assume the weather outside is 110 degree Fahrenheit, right? Okay, nice summer day. What will people do? Stay indoors, AC, juice, and stuff like that. So, so what happens here is that the number of people that are attending the place, right? But that are attending things and going outside is inversely proportional to the temperature that's outside. The more hotter it is, lesser people show up, and vice versa. And if it's cold, we all know we all went to Ooty, Shimla, Sweden, or whatever, and people love the cold weather. So as soon as the temperature drops, people love to come out and go, right? So more people, less temperature. But this is just a simple example. This may not be true for an entire degree. For example, you can never see 0 degrees Celsius in Coimbatore. These are outliers, but we're just saying based on the existing data of whatever Coimbatore or whatever city has recorded. I'm from Coimbatore, so I'm saying Coimbatore. So whatever city has recorded, the lesser the temperature, more people spend time outside. The more the temperature, people try to stay in. Okay, so this is called, this is what we saw. A plus one is a positive correlation, meaning that the values are directly proportional to whatever happens. And if it's negative, it's inversely proportional. So the closer the value gets to one, let's see. This is a sample graph that I made. This is called a correlation matrix. Okay, you might use it. Uh, so what happens is that this is just a simple graph. Week, you can see 111. Okay, so let's read this graph. What this actually means. Okay, there is this parameter, or there is this column, or there is this phenomenon, or whatever. Week is a time. Okay, so what this time is that the time is what happens to KC points. Let's assume KC points is a game. Okay, so in the game you get some points. The less, the more. I'm sorry. Okay, good. So what happens? 0.57. As you can see, if it's plus one, it's insanely close. If it's minus one, it's insanely. I mean, it's not close at all. So the more closer it comes, it means that if it's closer to one, it means that it's directly proportional. Points will increase as weeks go, and points will decrease as weeks come back. Okay, so this is one simple example of correlation. I want you guys to understand that this might actually seem simple, but it's very important that you know this. For example, in your case, for all the teachers and aspiring teachers and faculties over there, you can see that, for example, let's see, if a student gets more attendance, he's bound to score more, right? It's more of a, you can't actually accurately predict it, but someone who turns up to school regularly, does all their work, is bound to do more stuff. So that's called a direct correlation. So if we were to plot all these things in a correlation matrix, then we would get, the attendance and the marks. I have made a program about this, like pretty later on. We'll see what that is later. Okay. So I hope the concept of correlation is okay. Just to reiterate, my plus one is like really, really directly proportional, minus one is inversely proportional, and zero means there's absolutely no correlation at all. Good? Okay. So zero point 0.5 or zero point 0.6, I mean, anything more than zero point 0.6 is called a strong correlation. One rarely ever comes. Maybe sometimes it does in very synthetic data, but in real life, there's a less chance that you get perfect ones and minus ones. And again, the more closer to negative we get, the more inversely proportional they are. So this is the first topic that I would love to cover. I hope everyone has understood. Can someone actually, say that you understand it, or you can use the chat box. Do anyone have any doubt or something? You could use the chat box. I'm looking at it right now. If there is anything you would like to ask. All right, cool. I guess we'll move on to the next one then. Okay, so the next one is a bit, interesting, I would say. This is called linear regression. I hope all the math guys here know what that means. I'm pretty sure you guys do. So we'll get on with it. Okay, so linear regression is a statistical method, that actually brings in relationships between a target variable and the variable that affects everything over there, right? Okay, as you can see, these images look pretty nice. So this is the x-axis, and this is the y-axis. Y-axis is usually a target. A target can be anything. In your case, if something you're familiar with, is simply student marks, student grades, or whatever you want to look into. Okay, that can be the target, which can be y. And the B naught is the coefficient. Coefficient is simply a mathematical term that we add to make sure that this equals that. The LHS equals RHS. And then B1 X1. Okay. So, or beta 1 X1, whatever. So what beta 1 and X means is that X is one of the factors that influence Y. And beta 1 is a coefficient which actually defines how strong the relationship is with Y. This is actually kind of gaining close to correlation territory, but you can understand what I say, I hope, right? And then epsilon, or sometimes it's C, which is a constant value. Okay, regardless of what happens, the constant stays constant, yes? Cool. Okay, so this is our linear regression. To give you a real life example, that would be something like, let's say, does anyone have any sort of an example that they could give me? It's pretty simple. There's a target, you predict something, or you can tell me an example where I could simply just say, hey, you can use this, you can use that, frame it as an answer. Does anyone want to volunteer? I give you like 20 seconds. You can use the chat box. I mean, if you did use it, please tell me because I'm presenting the screen. Okay. Yeah. Okay, then I guess I don't have. I will check the chat box just in case if any of you have, Yeah. Let me see. Chat box is empty. Nice. Cool. Guess we'll go out to the presentation then. Okay, so we'll start with this. Okay, so I'll give you an example of what a target is and what factors that affect the target are. For instance, the target is Y. What can be Y? A target. Let's say, the marks example is pretty boring. If anyone has got better examples, they could say. But if not, I could actually go with something very generic, like the price of a house. Everyone wants a house, or perhaps everyone lives in a house at least. So this is familiar. So when you guys buy a house, what do you look? What actually makes you think that, oh, this is worth the expense I'm spending? I don't know. I'm spending like 10 million rupees for a house or something. So what makes this house worth 10 million? There can be some factors, right? So the simple factors over there are simply just, it can be a lot of things. Like, we'll see. First one is probably the area, which is like very, very, very obvious. The number of hectares or acres of land you own. That is a huge factor. And the size of the house itself. House sizes are usually calculated in square foot or some more like more, let's say, more relatable terms, such as the BHK or the bathroom hall kitchen or something. Sorry, bathroom hall kitchen. Yeah. So a 3 BHK or a 4 BHK house is certainly more to cost than a 1 BHK house, right, in the same area. So we can see that the primary price of the house is, am I audible? I hope I am. Okay, so the primary purpose of all these things, right? So how can a house be, calculated? The value of a house be calculated? That can be the target. We can see the target, let's say 1 million for simplicity's sake. Say nobody's selling a house for 1 million, but we can say, right? 1 million is Y, and then P naught is can be the predictor. And B1, let's just leave it. Let's assume that X is something that is related to house. Let's say square foot. The more square foot the house has, the more price it has. The lesser square foot it has, the less price it has. Yes? And then B2, B3, X1, X2. There's a lot of things. What can X1 and X2 be? A bunch of, bedrooms, maybe the number of bedrooms they have. And also something very interesting comes into play, which is the area or whatever. It's wherever it's located. So I think you guys got the gist of what a linear regression is. So we can actually substitute values, say y equal to b naught plus b1 x plus epsilon or whatever. So that is linear regression for you guys. So to read over the slides, let's see, that's the core concept. This is like the basic thing that a machine learning, that anyone stepping into AI should and must know, right? I don't care if you don't know how to do math, but I want you to at least understand that this is something that everyone needs, and this is how machines work, okay? And then the goal is to find a very good line that actually can predict what can happen. The reason why we have this line is because, let's say this line is an equation, okay? 2x plus 3y or something. So this equation, if we just throw it into the house, the next time someone asks you, right, what is the price of a house that is located at, a price of a house that's like 5,000 square feet, has 2 bedroom and hall for some reason, and whatever factors you want to add, this age of the house and stuff like that. So if someone asks you all these things, instead of just guessing and going on with it, you can simply say, hey, you can substitute all the values and find the answer if you really want to be smart about it. So since I've given you this example, you can integrate it into your school and college related stuff. For example, someone might say class 10A, random class, I don't know. So 10A has a performance of this much. This student is performing the best, and these are all the statistics. You take the data, you speak to it, you actually threaten it, and enough is enough, it will confess. Okay, you ask the data what happens and how it happens, and everybody is gonna get an answer for that. So you can say the performance of class depends on the number of students who show up and the number of students, let's say, even throw in events that are very disciplined or something like that. So that's linear regression for you guys. So that's simple enough. Is there any questions that you would like to ask regarding this? Okay, cool. All right, we have one more topic that we need to cover, just one more topic, and then we can jump into demos and stuff. After giving you your demo, I will just teach you how I've done it step by step, so you can maybe in the future do something with it. So the final one I would like to go through is simply just logistic regression. Logistic regression is kind of similar to linear regression, except for the fact that you're predicting something in that has a chance of happening or not. Will it rain tomorrow? I don't know. Will it? Probably not, because it rained yesterday. And regarding the rain and the stuff, what are the factors that affect the rain? Probably the humidity, probably the number of trees over there. Does that count? So all these stuff, logistic regression, that takes place. I'll show you a simple graph. So this is logistic regression, and it always lies between 0 and 1. Okay, it lies between 0 and it lies between 1. Okay, so what do you think lies between 0 and 1? They're not simple numbers. I'm pretty sure everybody knows the concept of probability, right? If it's like 0.9, it's a 90% chance of happening, and if it's not, if it's like less, that percent of happening. So it can never be negative. If you get it negative, you've done something wrong. Remember that. It's between 0 and 1. Okay. Cool. So we've covered the basic topics, and we can just jump straight into all the demos and how this works and stuff like that. If anyone has any questions, I'll give you about like 20 seconds for you to ask. I'll just wait for 20 seconds and prepare my code. If there's anything anyone would like to ask, please do ask. I'll give you 20 seconds.
Go ahead, Akshay.
All right. Okay. Let me just pull up my slide. Hold on a minute. Let me just run my code. Okay, guys, we're going to present my screen. All right, hope it's visible. Okay, so simple linear regression, we're gonna actually use something to predict the score of all people. I mean, all students. Sorry, right? Okay, so we'll go one by. Or maybe I'll just show the code at the starting. Okay, and then you can just figure out what we'll just figure it out step by step what anything means. Okay, so these are some imports that you're supposed to do. Please install everything, and then we're making a random seed and number of students so that the values always match. Yes. Okay, we have data frames, we have everything, we have plots and everything. So we just ran it in a single workbook. So what happened is that first of all, we're having something called the attendance percentage and the final marks. So what are attendance percentage and final marks? Attendance percentage is simply the percentage of attendance that I just generated. You guys can even throw in an Excel file or whatever file you guys have and just throw it. Over here, you can simply say read CSV or read Excel so that you guys can, enter your marks, student marks and everything, pre-processing and all that. But for simplicity's sake, since it's the first time, I hope, so I've just, used random data, okay? Good. So what happens is that I made a random data set, okay, and then made some graphs, and then there's a linear regression model, which says attendance percentage is the, final marks is the target and attendance percentage. We'll have one predictor, X, okay? So you just split it into training and testing and, split everything. And then there's a random string of 42. The reason, I'll come to this later, okay? And when it comes to machine learning, right? Machine learning is just essentially teaching what the machine wants to do, right? Our task is to help, make the machine understand the relationship between the attendance percentage and the final marks. Okay, I want my machine to learn about it. Good. Okay. After that, we have, we just split it into training and testing. You might ask, what is training and testing? Okay. Let's see. You guys have an exam, right? Pretty sure every one of us has written exams and read it. So what happens is that you get the data at the beginning, and then you split it into training and testing. Usually 70 to 80% of your data should be, training data, and 20 to 30% of data should be testing always. Okay, so what happens is the model is just linear regression, because of course we are going with linear regression, so we're doing that. And then model fit is X train or Y train. Okay, the reason why we use X train and Y train is because, of course, we train the model using that part. Okay, so this is a simple command which is model.predict of X test, and then there's the R2 score, which I will come back to later. And all these are just matplotlib and simple plotting tools that you can use. Yeah, so these are all just not part of machine learning, but these are all just simple graphs. Okay, okay, and then we have the new attendance. What happens? This is something that you can give. Okay, we can change the value and give something else. Okay, so this runs. So what happens at the end is, let's see, this is our sample data set. Let's assume this is an Excel file, okay, of hundreds and thousands of data. I can't find one because I'm no longer a student. Because I haven't been a student or gone near a school in so long. Okay, so attendance, final marks. Let's say they have 88% attendance, they have 71 marks, they have 78, they have 59, they have 64. You can get the idea. So from what we see here is just 5 data points, and then you can say, oh, more attendance with more mark. But let's imagine if we have like hundreds and hundreds of data. Okay, what would happen? So that's why we need machine learning for that stuff. So to make you guys visualize what happens, okay, we are actually plotting all the data points over here. So what happens is that attendance is this final mark, all the data points are plotted, okay? And then the R2 score is about 0.87, which is kind of good. And then finally, we have the actual marks and the regression line. And the regression line is the model you trained. Damn, look, the machine that knows absolutely nothing about it, about you or anything that exists, predicts the mark that the person can get. For example, if someone has like a 40 marks, they probably have about 52% of attendance. And if someone gets like a 50, they probably have like a 60-ish percentage of attendance. So the machine has actually predicted what the marks could be. And as you can see, all the data points over here are extremely close. See, all the data points are really close. So what does that mean? That means that predicted marks. So I just put a random value. Remember, 92% attendance. So for about 92% attendance, they might get like 74. So it's just the machine learns and it tries to understand what is happening in the data and then go with it. So that's what we have, to be honest. So that's the simplest thing that we could do with all these, predicting and stuff. I hope you guys can actually use some of it in your, you know what I mean, like marks or whatever audits you guys have. I hope this has been clear, and I will just go into how these things are made. Uh, okay, so are there any questions you would like to ask me, or I'll wait for like 30 seconds for a response. If I get something in the chat box, just tell me. Anyone?
I think teachers, I don't know how many of you are purely attentive, right? See, guys, every time we teach certain programs to the teachers, right, meaning to the students, it's not just about the technology. It's about the use cases of the technology, right? Even with the generative AI or even with the previous era's deep learning, machine learning part, the whole important aspect of it comes when the teachers themselves apply it for their needs, right? It could be just like what Akshay said, or it could be student mark analysis using the linear regression, because linear regression is most of the teachers, right, who happen to be the HODs or the junior teachers, right, senior teachers, right, most of you will be teaching this to the students. So what happens in the real world is we teach them, the students, about what the technology is and leave it. And students, on the other hand, they figure their way out to actually identify what the use cases are in the layer when they work as an IT professional or when they move on from their journey in whatever they do. But teachers, they continue to teach only based on it, but never think of applying that for their day-to-day needs, right? And that's where the problem, because they are so busy in NAC audits, they are so busy in doing the operational stuff, they are so busy doing the clerical stuff, but where is the time? Now, using the generative AI, we can actually build those code base, whatever Akshay is trying to do, right? You can, using the generative AI, you can build those Python structure, which will save around I would say 50 to 60% of the time, and still get the base done, right? So, which means you can literally start applying it for your day-to-day needs, which in other words is like student mark analysis or their other parameters to understand the skill level of a student, even if it is for the placement stuff, right? We have n number of use cases available. The point is the teacher in fraternity is unable to think out creatively to see how it can be effectively used for their needs. Am I right? Right? And these are the things I would say the people should be asking that in the FTP. So where is the use case? Can I use it here? Can I use in this place? Right? Can I use, because what is your pain area? You should first of all realize. But the problem right now is we love the pain area because it keeps us busy. We are not able to think out loud. We are not able to think out creatively. So that's where the actual learning starts. Right? How many of you all agree with me? At least whoever is attentive, I would like to hear. Right? If you all agree with me, just type a yes in the chat box. Let me see how many of you are able to actually type in the chat box. Type yes in whatever I've said, sir. Any setup. There are 62 members, right? So let me see the attentiveness of the people. How many of you agree with what I just specified? Thank you, ma'am. Yes, at least one, two. Thank you, Mr. Arun Prakash. Perfect. Yes, yes, yes. Right. Perfect. No, great job, Arunji. Right. These are the kind of, see, you are the classic example of a teacher, my friend. I'm telling you. Right. So I have been dealing with 70 plus colleges today. Right. And my only focus is to enable the teachers to be, think out creative, think out smart. Right. So I'm really glad when people say, so I'm trying the program as they are doing, I'm learning things, right? Not just coming for the sake of this 5 day certificate, but I really love that they are the creative teaching, they are the seeing the profession as divine. Thank you so much, Suganya ma'am, Uma, right? Arun Prakash ji, Jasula ma'am, very nice, right? And please do keep up that spirit, right? So let's continue now. Figure out ways how we can use that for our day-to-day needs. Because we are in the profession, let's think of use cases in our own jobs itself. If you need help to figure out what are the ways, I'm more than happy to actually help you guys. Good? Yes. Thank you for the responses. Absolutely. Yes, I think somebody wants to ask a question. Please. And tomorrow, my friends, it will have to be completely interactive because tomorrow being the final day, I myself will be leading the program, right? So with a lot more challenges, a lot more interactions would be expected. So please, watch out for that, right? So yes, somebody's raised a hand. Who was that, ma'am, sir? Who wants to ask? Please unmute yourself and speak, sir, or ma'am. I just saw a hand. Okay, never mind. Okay, actually, yeah. What next? What is that second topic?
Well, I have another program that I would like to show, which is kind of similar. And then, if anyone has any questions, they can ask. I could go through the basics, teach them.
Yeah, no, that's fine. Yeah, basics,
Yeah,
right?
and
Because as part of our deep dive workshops, we can definitely cover those. But again, right, anything which you feel quickly that it will trigger the thoughts of the teachers where they can start applying that. And now, one you very well showed about this linear regression model, correct? How for the
yes.
student evaluation themselves we can use that, right? So we can build that model, and the teachers can put time and frame and energy to actually build on it. What was the next one, Akshay?
Yeah, there's something similar that actually shows teacher experience and students' performance. It's kind of similar, but we use random forest regressor.
Okay,
All right,
just
that yeah.
just bring it up
And
on screen. That's you. Yeah.
all right. So, guys, I'll bring this up. If any questions, do ask because I can't see you guys when you're presenting. When I'm presenting, okay? So we'll share again. All right. Oh, same thing, different thing. Yeah. Oh, okay. Hope you can see we use pandas and stuff like that, which is nice. So okay, so since we've actually gone through something similar, this time I'll go a bit slow and tell you what pandas are. Pandas are, libraries. It's a like Python library, very versatile Python library that can take Excel files, CSV files, and even data frames, create data frames. What is a data frame? It's where you store data and make sure that Python understands all. NumPys are simply used to manipulate arrays, and sklearn is simply nothing but scikit-learn. Okay, you can install it, and then train test split is a module within sklearn, and then random forest regressor. We'll come to that later, but it's a different algorithm. I'm not sure if we have time to do it because I'll explain, and the last few minutes are open for questions. And then we have artist code, mean absolute error, and matplotlib. And something about matplotlib is nothing but it's just a graphing tool. Like there's nothing too complex about it. They are used to make graphs in Python. Okay, first one, load a data set. Google file, import files. Yeah, I have my own file. Like I did it a little while ago. And then academic performance data dummy data set that I created. And then if the data is loaded, it will go data is loaded successfully. If not, it's gonna throw you an error. Okay, cool. So what happens is that again, this is a sample data set. We have about, let's say, the student ID, the department, and the attendance, internal assessment. There's a bunch of things that you guys are all familiar with. And then we have the total. Okay.
Actually, let's go a little slow, right? So just wait on the data set, right? What does the data set say? So you have the student ID, department, attendance percentage, internal assessments, and the teacher's experience, basically.
Yeah,
right?
This is something. This is.
And what is the final semester marks?
Final semester marks is the marks that the student gets at the end of the semester. You just add it. Yeah.
Okay, it's a cumulative figure, right?
Yeah, and
Okay.
again, this isn't
Okay,
real.
and tell me what this tell team what this does actually. What this algorithm does for these and under this data set, what it reads and what is the value it creates.
Okay. For that, I need to scroll down and show you.
Yeah.
Is that okay? Okay, let's go. So what happens is that, this is a graph, never mind. Our end goal is to find if...
Let's do a reverse engineering, right? Show them.
Yeah. Okay, so this is the final thing that you have, okay? So what we do, for example, in colleges and schools, you might think, of hiring faculties and stuff, you might think, does experience really matter? Well, in this data set, apparently it does, okay? The more experience a faculty has, the more marks their students score. This is something that this data set actually tells us. Again, I don't want to point fingers, and this isn't real, but this is kind of a, example of how you could use it. Again, teaching depends on skill, but again, experience matters a lot. So this data set, this particular data set's output shows that, hey, if you have more experience, the students are bound to get more scores. Okay, this is something that we found out through this data set. This graph is a testament to it. As you can see, someone who has less experience has 120 score, and then it goes up, goes down, goes up, goes down. And the one recurring pattern that we see is that the more the experience, the higher it is. It's what we kind of think, but again, it kind of goes down at the end. So, but this is a general theme because humans are not perfect, but a random data set. So this is the output. So as Mr. Arun said, we could probably reverse engineer from it. How did we get this? It's kind of a question, right? Your nice little machine draws some squiggly lines. What does it mean? How do we get it? We'll go up and go step by step to make sure that we understand what happens, okay? Cool, all these graphs and stuff. And then there's something called data pre-processing. I'm pretty sure schools still use Excel. Yes, schools and colleges use Excel. Pretty sure a lot of people use Excel. So what happens is that data frame is get dummies and you get the column. So what happens is that drop first is true. For instance, you don't need department. But this is something important, you guys. When you're trying to predict something, okay, you can see that I've dropped department and I've dropped student ID and stuff. The reason why is pretty simple and pretty intuitive if you think about it. The marks of a student does not depend on his name or whatever roll number he has, right? It depends on his performance. And the marks of a student does not depend on the department alone. Sure, some departments are harder than others, but they do not purely depend on department alone. Yes? So that is something we need to know. Next, what happens is the random forest regressor. This is a bit complex. I'm not sure if we have time to go through it, but I want you guys to understand that random forest regression is a tree-based model, which actually shows you how things are done based on the previous decision. I hope you guys know about decision trees. Um, okay, let's say decision trees. Let's say whatever decision that, or output that you've done before, that will depend on whatever you're gonna do, or vice versa. Yeah, whatever you're gonna do now will depend on what has happened before. So that's how I mean random forest regressor works. And the random state 42, I told you I covered it, right? Which means this can be any number, 100 or 30 or whatever. That means that the machine will run the same way it ran as before. This is done to replicate results, okay? And then you have the very famous model fit, and then you have the predicting test, and then the R2 score, and then the mean absolute error, an R2 score, and mean absolute error. Okay, I'll just come back to R2 score because I want to show you a formula. Okay, and the mean absolute error is the, you just get the predicted value and your actual value subtracted to get it. Okay, and you get the average of it. That's called mean average value. Okay, and then we have pandas we are using again, model importances, and then we took the index from over there. Okay, I'm sure you guys can see this again, test size and train size. Okay, and then these are graphing tools. This might be useful for you guys. So uh PLT importance is something that we predicted, and I mean something that we defined before. And then importance dot plot means you're just simply plotting the color. The color can be anything, sky blue, black, whatever. And then the title, the label, show means it shows. And then these are the sprint statements that we gave. Okay, so this data set looks a bit weird. And then we are ranking importance. Okay, what are importance? Importance means the influencing factors of the some final semester marks. As you can see, it's mid-sem marks, it's experience, it's assignment score, and everything else. Now you might tell me, oh my god, you said experience actually played a lot, but what about sem marks? But this is pretty, kind of intuitive because the student who scores higher in the before semester will always score higher in the next one. So that's kind of a given, right? So that's a major part. And after that, we have attendance and teacher experience in years. So this one can be kind of ignored, to be honest, but I just want to show you how things play out. And at the end, we have attendance, assignment score, and everything at the end. Okay. And then we have top factors influencing. All these means, 0.78. Remember correlation, the higher the number, the better the, impact. So with some marks 0.78, attendance is a bit less, teacher experience is way too less, but at least this is a given. So the next best thing we have is this term. Okay. And then, the model, we are doing this because we're gonna predict a new one. Obviously, we don't have real data, so I just made attendance percentage or whatever you gotta do. Some data that I entered on my own end, and I did it. And then align columns, yeah, all these things. So if any missing columns are there, you just put 0 and model dot columns, and the final one is what we saw at the beginning. And then we want to see teacher experience and final semester marks. Then we have some sort of an output, which is a graph. Okay, so that's what RF regressor does in general. It's kind of similar to all these linear regression stuff, but imagine iterating decisions over decisions. So this will give you more accuracy. Another tip I want you to add that since these are all supervised learning techniques, please note it. Supervised learning techniques and unsupervised learning techniques. Supervised is what we use majority of the time because unsupervised, we're not going to build a image model yet. I don't think it will be useful for schools. Maybe for attendance tracking, maybe. But we won't be using that for schools. So supervised learning models, these are the basics: the linear regression, logistic regression, and random forest regression. Linear regression is a simple thing. Random forest regression has usually a higher accuracy rate. And all the data you see, all these are real. So these are all just to teach you guys. I want you guys to try to use it in real data, right? So that you guys can get a better result. Always, if you have more things to learn, the machine learns better. I can actually give an example for this. For example, if a student reads more books, what will happen? He gets a lot more knowledge than others, and then he learns. right? So that's what the fundamentals of machine learning is about. Have good data, have very clean quality data. I want you guys to go through pre-processing very well because this is just very simple pre-processing. There's a bunch of encoding and stuff too, but I want to just give you guys the idea of how this stuff works. So this is encoding and everything. I mean, not encoding. We're just excluding columns that we don't need, and this is called cleaning, data cleaning or data pre-processing, interchangeably you can call it. After that, you can go through everything and throw your data in. It can be Excel, it can be CSV. If you if you're using a database, good luck. Same, you can just use MySQL connector or whatever database you use. Throw your marks in, and I want you guys to train a model with estimators and stuff. And that's it, guys. I don't think it's too complex. I hope it was, you understood a bit. It may not be too complex for me or anyone. But I did this because I want you guys to get to the building blocks of machine learning and just confidently step into the world and say, hey, I know machine learning. There's nothing. ChatGPT is in magic. All these weather predictor people are in magic. All these things are just math. So that's it. I mean, those are the things for today. We have around 5 to 10 minutes, yeah, 9 minutes left. I can go through, some models regarding pandas and stuff. And if you guys have any other doubt, please feel free to reach out. I've kept the chat box open. Hold on. Any chats? Okay, cool. All right. Sounds good. So I hope you understood the basics and you guys on how to integrate stuff into your work. If there's anything you would like to know, can you please ping me or just ask me? This is yours, floor. The stage is yours. That's it, guys. You want to ask me something?
So before the team walks in tomorrow, friends, right? I would at least request, let me see how many of you are able to really think out. One productive, right? It's a task. Let's consider this as a simple assignment, right? Identify one use case, right, in your routine. Any one use case. It should be the top one, right, which is the most painful area, right? Just one use case which you think can be either built using AI or leverage any of the machine learning part. It could be video related or anything for that matter. It could be an agent, anything. You can simply identify uh, one use case, right? So if you all promise me tomorrow, we can build things from there, and then let's see how that momentum is built. So if you don't have any further questions, ladies and gentlemen, we can pause here. Over to you, ma'am, and we are good.
Participants, any queries?
Well, guys, if you can even ask like personal questions like, hey, I'm building a new model or an AI something that I want to build, I want to make money with, or something like that. You can ask. The stage is yours. If you're too shy to just talk, you can use the chat box too because I'm there for you guys. So just ask away or text. I'll be waiting.